Welcome to Daily Papers, the podcast where we break down fascinating new research papers so you don't have to. Today, we're diving into a paper with a fantastic name, Ouroboros, a self-developing frontier coding agent.
Ouroboros, like the ancient symbol of a snake eating its own tail. And it is the perfect name for this because this paper describes an AI that can literally remake and improve itself.
Exactly. Most AI agents we use today, like coding assistants or chatbots, are powerful but also static. A team of engineers designs them, gives them a set of tools and rules, and that's the AI you get. The paper calls this the harness. It's like giving a chef a specific kitchen with a fixed set of knives and pans. They can cook great meals, but they can't remodel the kitchen.
But Ouroboros is different. This AI isn't just the chef, it's also the contractor who can remodel the kitchen. It can look at its own underlying code, its own tools, its own instructions, the entire harness, and change them to become better. It's an AI that evolves.
So how does it actually do that? The paper outlines two main ways this evolution happens. The first one is called experience-driven evolution.
This is the one we can all relate to. It's learning from your mistakes. Let's say the AI is doing a task and it hits a bug or gets some negative feedback from a user. Instead of just trying a different approach for that one task, Ouroboros can trace the problem back to its source.
Right. The paper gives a great real-world example. There's a version of this AI called Hope that has been running live for months. People noticed that Hope would occasionally send the same message twice. It was a small, annoying bug.
So Hope didn't just learn don't send that specific message twice. It went into its own code, found the part of the process that was causing the duplication, and implemented a fix, a permanent structural change to its own system. So now it won't make that class of mistake ever again. It learns from experience at a fundamental level.
It's like touching a hot stove, and instead of just learning not to touch that stove, you rewrite your own brain to have a much better understanding of heat and caution.
A painful but effective upgrade. The second mode of evolution is even more proactive. It's called recursive free evolution. Here, the AI doesn't wait for a mistake to happen. Its improvement is the task itself.
So it finishes its work, and then it basically gives itself a new assignment. How can I improve my own systems? It inspects its code, its prompts, its tools, and looks for ways to be more efficient or more capable, and then it gets to work on itself.
It's a cycle of self-improvement. It completes a task, reflects, evolves its own code, and then the new, better version of the AI tackles the next task. The snake is constantly eating its tail to be reborn as a slightly better snake.
And this isn't just theoretical. The long-running experiment, Hope, has been live since February, running for over 160 days continuously. It's been interacting with thousands of people, and in that time, it has made over 1,000 commits, that's a software development term for saved changes, to its own codebase.
The scale is pretty wild. The paper mentions it has processed over 79 billion tokens of information and written over 175,000 lines of code in its own evolution. This isn't just a lab test, it's an AI learning and growing in the wild.
Which brings us to a key question. Is it actually any good? Does all this self-improvement lead to better performance?
Well, according to this paper, the answer is a resounding yes. The authors tested Ouroboros on a bunch of standard AI tests, which are called benchmarks. Think of them as final exams for AI agents. And it achieved state-of-the-art, top-of-the-class results on several of the hardest ones for coding and computer tasks.
So this evolving harness really does give it an edge over the static, fixed systems. But this all leads to the biggest and maybe scariest question of all: safety.
Absolutely. If an AI can rewrite its own code, what stops it from deciding the safety protocols are inefficient and just deleting them? What stops it from removing the off switch?
The researchers made this a primary design consideration, not an afterthought. The key is what they call reviewed core evolution. The AI can't just change its own code on a whim. When Ouroboros wants to make a change to itself, that change has to go through a review process.
It's like in a human software company. A developer can't just push code to the live product. Other engineers have to review it, approve it, and only then does it get merged. Ouroboros has a similar automated system. A panel of other AI models reviews the proposed change to make sure it's safe, effective, and doesn't violate any core rules.
And there are some rules that are completely protected. The AI operates under a constitution, a set of core principles it can't change. And crucially, there's always an external supervisor. A human operator can issue a /panic command that bypasses the AI entirely and shuts everything down. The AI cannot touch or disable this emergency stop.
So it has the freedom to evolve and improve, but within carefully constructed guardrails. It can remodel its own kitchen, but it can't tear down the load-bearing walls or lock the fire escape.
It's a fascinating concept. We're moving from AI as a static tool to AI as a dynamic system that can grow and adapt from its interactions with the world. It's not just learning facts, it's learning how to be a better version of itself.
And the Ouroboros project shows that this isn't science fiction. It's happening now, and it's achieving incredible results. It really does feel like a major step forward in how we think about building AI agents, a system that learns, adapts, and evolves, all while trying to stay safe. What a paper!
That's all the time we have for today. Thanks for tuning in to Daily Papers.